Multimodal ingestion pipeline, text plus docs, audio, images. Big idea, one sentence. You take messy multimodal files in S3 and run them through a step functions assembly line to extract text structure, then store standard JSON for search, analytics, and prompting. How 1? The AWS assembly line architecture, exam perfect. Mini lab design you mentioned. You can see the code in our conversation history. What each piece does. S3, the landing zone for uploads, PDFs, JPGs, MP3s, etc. EventBridge detects the upload event and triggers processing. Step functions orchestrates multi-step workflow, retry branching failures. Textract extracts text plus tables forms from document scans. Transcribe turns audio into text transcripts. Rekognition detects labels, text, faces, moderation, and images depending on use. S3 output stores normalized JSON results per file, your single truth format. Now 2, Static 1, Multimodal Edition. Static fixed rules, which extractor to use for each file type. Confidence thresholds, output JSON schema, retry backoff rules where outputs are stored. Dynamic input, the uploaded file, type, metadata, content, that's Static+1, fixed pipeline rules, changing files. Header 3, how step functions branches by file type, core concept. The step function starts with a what is this file step. If .pdf or .png/jpg scan Textract, if .m3 wave transcribe, if .jpng image Rekognition, if .txt basic text normalization, then it routes to the right extraction path. Exam signal. If you see multiple file types, orchestration, retries, branching step functions. Hammer 4, what the structured JSON output typically looks like, realistic. You want one consistent envelope so downstream systems don't care about file type. Example output JSON, shape, not exact, AWS output. You can see the code in our conversation history. For audio transcripts, you can see the code in our conversation history. For images, you can see the code in our conversation history. Number 5, reliability patterns inside the pipeline. Exam loves these. Check, retries plus backoff. Textract transcribe may throttle or fail temporarily. Step functions retries with backoff, dead letter handling. If extraction fails after retries, store a failure JSON, send alert, SNS, EventBridge. Idempotency. If the same file triggers twice, don't duplicate results. Store output with deterministic key. Number 6, memory story, so you don't forget. The sorting factory. Imagine a factory conveyor belt. Boxes arrive at the loading dock, S3 upload. A bell rings and tells the factory, new box arrived, EventBridge. The factory manager routes the box to the right machine, step functions. The machines, document shredder reader, Textract, audio stenographer, transcribe, image detective, Rekognition. Everything is rewritten into the same standardized report format, structured JSON in S3. The trick is, the factory doesn't care what the box looked like, it always outputs the same kind of report. That's multimodal ingestion. The mini lab in one sentence. A user uploads a file to S3, an event fires, step functions runs the right extractor, Textract, transcribe, Rekognition, and the result is saved as a clean JSON file that downstream systems can use. Number 1, a concrete example in Manchester. Step 0, upload to S3. A user uploads patient intake 01.pdf. It lands in S3/myingestion bucket uploads patient intake 01.pdf. S3 is your landing zone. Nothing else happens yet. Step 1. EventBridge notices the upload S3 emits an event like object created. EventBridge rule listens for bucket equals myingestion bucket, prefix equals upload/, event type equals object created. When it matches, EventBridge triggers your step function state machine and passes the object info, bucket, key path, size, timestamp. Why EventBridge? Because it's the clean event router for AWS. It decouples ingestion from processing. Step 2. Step functions runs the workflow, the factory manager. Step functions receives bucket, myingestion bucket, key, uploads, patient intake 001.pdf. Now it runs the workflow. 1. Detect file type, PDF, audio, image. 2. Branch to the correct extractor. 3. Normalize the extractor output into your standard JSON format. 4. Store JSON in an output location. 5. If anything fails, retry backoff, then store error JSON plus notify. Step 3. Extract Textract for docs. Because it's a PDF, step functions routes to Textract. Textract extracts raw text, key value pairs, forms, tables, if any. Step 4. Store structured JSON, the single truth format. Step Functions writes a JSON output file to S3 my ingestion buckets processed patient intake 001.json. Now your RAG system/database app can read JSON without caring it came from a PDF. 2. The same pipeline but with audio and images. Example A, audio call recording. Upload calls call772.wav. Step Functions routes to transcribe, then outputs. Process calls call772.json. Example B, photo of a receipt. Upload/images receipt.jpg. Step Functions routes to Rekognition, labels text detection, outputs. Processed images receipt.json. The exact same pipeline works, only the extractor changes. Number 3, what Step Functions looks like logically. Super clear. Think of your state machine like this. State 1, get object metadata. Read S3 key, size, content type, determine extension. State 2, choose extractor, choice state. If file ends with .pdf or is a scanned image, Textract branch. If .wav/mp3, transcribe branch. If image, Rekognition branch, else fallback branch, unsupported file type. State 3, run extractor. Call the service. State 4, normalize to standard JSON. Convert raw service output, your unified JSON schema. State 5, write output. Save to processed / JSON error handling. Retry with backoff. On permanent fail, save error JSON notify. This is exactly why Step Functions is used. It's built for branching plus retries, failure handling. Number 4, what structured JSON actually means. Real example. Textract output normalized example. You can see the code in our conversation history. Transcribe normalized example. You can see the code in our conversation history. Rekognition normalized example. You can see the code in our conversation history. Notice the trick. All outputs have the same envelope: source, extraction, content, metadata. This makes your downstream code dead simple. Number 5, why this pipeline is exam correct. The key reasoning. If AWS asks for multiple file types, orchestration, retries, branching, consistent output, your answer should naturally include S3 plus EventBridge plus Step Functions plus the right extractor service. Tiny memory story, so it sticks. S3 is the mailbox. EventBridge is the doorbell. Step Functions is the receptionist. Textract, Transcribe, Rekognition are the specialists. Structured JSON is the patient chart.